So if I go from B to D, what can I do? I could go to C, right? I haven't done that yet. So BDC. What else? So BDCA. Haven't done that. What else are we missing? We don't have E yet, right? So BDCAE. We're done. We have all the vertices, A, B, C, D, E, so we can finally come back to the starting vertex. So I'm at E, so I just come back to B, EB. So again, we started with this edge over here, ED, and we went through and we got all the vertices, and we ended up with the same one at the end. That's one option. Let's try another one. Okay, so again, I have to start with edge BD, that's specified. So I could do BD, I did BDC last time, why not do BDE? Why not? So BDE. I can't go back to B because it has to be all the way at the end. So I'm at E right now, so I could go to A, right? We haven't seen that one. So BDEA. We haven't done C, so C. We're done. We got all the vertices. A, B, C, D, E. So I can finally go back from C back to my starting vertex, which is B. So these are both, Hamiltonian circuits. Does it make sense?
All good.
Okay, so not so difficult. A lot of it is more visual compared to, equations and other things that we see in math. So this is more about looking at it and following the criteria to finish the problem, basically. Okay, so there's a theorem in math stating how many Hamilton circuits a graph can have, depending on the number of vertices the graph contains. So this exclamation point means, let's say I have n vertices in the graph. Then there's going to be n minus 1 factorial. That exclamation point means factorial in mathematics. Let me explain what a factorial is, first of all. You copy that, and then I'll explain it. It's very easy. So let's say I want to find 4 factorial in math. All it is it's going to be 4 times 3 times 2 times 1. So basically you're going from 4 all the way down to 1 and multiplying the numbers out. So 24. 5 factorial would be 5 times 4 times 3 times 2 times 1, 120. See the pattern? So if I wanted to find, 2 factorial, it would just be 2 times 1, which is 2. So I'm telling you that it has n minus 1 factorial circuits in it. I think it's n minus 1 factorial. So let's look at an example, I guess. Very simple one. See if this works or not. Okay, so let's say I have this graph with 3 vertices in it. So it looks like a triangle, right? So I have n equals 3 vertices in this. And so how many Hamiltonian circuits am I going to have? N minus 1 factorial is what I have to do. So that's 2 factorial, which is 2. So there's going to be 2 circuits in this one. So there's going to be 2 distinct circuits I can get from this. So let's see what the distinct circuits are going to be. So let's say I start with vertex A. So there's going to be 2 circuits total, right? 2 Hamilton circuits, according to the formula. Total. So what are my options? If I start with A, I go A, B, C, right? A, B, C, A. So A, B, C, A. That's 1. What else? Well, I could do A, so that would be, I went A, B, so I'd have to go A, C, B, A. A, C, B, A would be another one. 2. So we have 2, right? As you can see. 2 distinct, unique Hamilton circuits. Of course, we can always have a lot more, right? If I made it more complicated.